the Always Believe House. Oh, today we're going to talk about actually solving quadratic functions. When you solve a quadratic function, basically you're finding the zero, and hopefully you remember the zero is the x-intercept. The easiest way to do that is just to graph it. You can always graph the quadratic functions and trace to the zeros. That's what I'm going to teach you to do today. So a magical whiteboard appears, and let's start rocking and rolling about finding zeros of functions. Ho, 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 ho. Okay, so the first one, the definition. Let's write down a zero. A zero is the input of a function that outputs a zero. And remember, a function could have more than one zero. Technically, it is the x that outputs a zero. And it's the x-intercept in it. So what number can I put in the function that will output a zero? If the function has an exponent of 2, it will have at most 2 zeros. In algebra 2, you'll have exponent of 3. That will be a cubic equation. It could have 3 zeros. Okay, so this is also called a zero. It's also called the x-intercept. And you can also say it's the root of a function. So all of these are the numbers that you input to output a zero, okay? And it will always look like this, okay? That's the x-intercept. Now then, let's go to this. If it has two solutions, let's say here and here, the graph would look like this, wouldn't it? Okay? Most parabolas that you do in Algebra 1 will have two solutions. If it has one solution, the vertex is going to be on the x-axis. And this is what it would look like. It would look like x minus 3 times x minus 3. Notice the factors are the same. If the factors are the same, this is going to be one solution, okay? Because each factor is going to be a positive 3 for the zero in it. If you multiply this, you would get x squared minus 6x plus 9. If you were to graph that, you would only get one zero, and the zero would be at 3. And lastly, a no solution would look like this. The parabola would not cross the x-axis, and you would not get any zeros, okay? You would just write down no real solution. Okay, so let's go to some examples here. X squared plus 4x minus 5. The easiest way to do this, find the solutions by graphing, is just to graph it and trace, okay? So let's go to the calculator. I'm going to get rid of my table, Control T, hit delete, delete, delete. Hit enter. Now then, I'm just going to graph that first problem, okay? So the first problem, let me go to the right thing, is x squared plus 4x minus 5. So I'm going to hit the tab. X squared plus 4x, is it minus 5? X squared plus 4x minus 5, that's correct. Hit enter. Notice I get a parabola. I can't see the bottom of it, that's fine. And I'm going to trace to these two zeros. So menu, graph traces 5, and then 1, and I'm just going to hit the right arrow button. It looks like it's going to be 1, isn't it? And notice at 1 it is 0. So notice the x is 1, the output 0. So if I input 1, I output 0. Now then, instead of hitting the left arrow button and going all the way around, 1, 2, 3, 4, just type in -4 and enter. -4 and enter, and it swings it around to -4. Y'all got that? Hit the left arrow button until it gets to that x-axis, and boom, it's there at -5, 0 in it. So -5 and positive 1 are my zeros. So I'm going to go back here, and let's just do, let's start this one with -5, 0, then -4, -3, -2, -1, 0, and 1. And then let's go to here and hit Control T to get the table. And then these are the ordered pairs I'm going to write down, right? Okay, so -5, -8, -9. -5, -8, -9, and they just flip across. Ho, 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 ho. Now then remember, this is the y-intercept, and this number and this number are your zeros. There's a big difference. The y-intercept has a 0 on the left. The x-intercept has a 0 on the right. And if you were to graph this, the solutions on this would be x equals -5 and 1. And then if you were to graph, it would be -5, 0, 1, 0. The vertex is at -2, -9. And then remember that pattern, over 1, up 1, over 2, up 4. That's always going to work. So right here, and the vertex or the parabola would look like this, wouldn't it? Okay, so all we're wanting is this point and this point, which is -5 and 1. Those are your zeros, aren't they? Piece of cake. All you got to do is grab these, hit Control-T, and copy down the table. Piece of cake, okay? Let's go to the next one. Okay, x squared minus 2x plus 1. I've got to start you off on this and let you finish the last two. So I'm going to go to the calculator, hit Control-T. Get rid of that, then delete, 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 hit enter, and then hit tab. That gives me my next function. And then x squared minus, notice that the a is 1 in it. This one's going to get flipped though, right? Number 3 will be flipped. But if the a is 1, that pattern of over 1, up 1, over 2, up 4 will always be there, okay? From the parent function, okay? So let's graph x squared minus 2x plus 1. So x squared minus 2x plus 1, then hit enter. Notice this crosses the parabola once, doesn't it? So if I hit menu, graph trace, which is 5, and then graph 1, and then hit the right arrow button when I get to my 0, does it say 0 or minimum? It says minimum, but notice 1, 0. If you input 1, you output 0, don't you? Okay, so I'm going to go to here, row 1, and put 1, 0 right in the middle. And now then, let's go back to the calculator, hit Control-T. And notice, this is the table I'm going to graph it in. So 2, notice that the 2 right here, 2, 1, 4, 9, those are the perfect squares, aren't they? Because we did not change the a value. Okay, so go back to here. So 2 would be 4, 2 would be 1. 3 would be 4, 4 would be 9, and then 0 would be 1, -1 would be 4, and -2 would be 9. These numbers are going to flip, aren't they? Because it's symmetrical. This number right here is your 0, and this right here is your y-intercept. The zeros in opposite spaces, right? Something you need to remember. And then to graph this, over 1, then over 2, up 4, over 2, up 4, over 3, up 9. And then we would have our graph. It would look something like this, right? And it would have 1, 0, which would be at 1, right? So x equals 1 on this one. I'll let you do the next one on your own. It's going to flip, right? Remember, you'll put your vertex right here, and then put 3 points above, 3 points below. Get it from the table. Find your zeros, okay? Okay, now then on this one right here, you're just going to graph and find the x-intercept, or find the roots and the y-intercept. That's all you have to do. I'm only going to do a couple of these, okay? So let's go to number 1. 3x squared plus 12x minus 96. So hit hit tab. I didn't want to do that. Hit Control-T. Get rid of the table. There we go. Delete, delete, delete. Hit enter. Now then I'm going to graph 3x squared plus 12x minus 96. So tab, 3x squared plus 12x minus 96. Notice on this one, the y-intercept is at -96. That's way, way down in it. So when we trace this, we're going to go way, way down. We will not see this graph, will we? When we graph it. Let me make sure I got it right. 3x squared plus 12x minus 96. So I'm going to hit enter. And we only see the left and right part. We don't see the bottom, do we? But notice here, I can count 1, 2, 3. My y-intercept is going to probably be at 4 in it. Okay? So hit menu, 5, 1. And then I'm just going to type in 3 and enter. If I type in 3 and enter, it goes way up, right? Now then I'm just going to keep hitting the left arrow button. And we get to the 0 at 4, right? 4 comma 0 is there. Now then go backwards, count 1, 2, 3, 4, 5, 6, 7. Just type in -7. -7, hit enter, and it swings it all the way around. Go left and keep hitting the up arrow. There's my other zeros, so -8. So -8 and 4 are my zeros, and the -96 was the y. So if I hit 0, enter, the -96 is the y-intercept in it. Okay, so let's go back to here. Remember, this is going to be our y-intercept, and the zeros were, what again? Hit 4, enter. They were 4 and -8, weren't they? So x equals 4 and -8. Those are the zeros, okay? Piece of cake. Piece of cake. All you got to do is graph it. And remember, your y-intercept is going to be the c. Let's write this down. ax squared plus bx plus c. This right here will be your y-intercept. Notice on number 3, there's no c, is there? So the y-intercept is going to be 0, okay? I'm going to do number 3 with you and just let you finish up, okay? So on number 3, I'm going to go to the calculator, hit delete, 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 hit enter, then hit the tab button. Now then I'm going to grab 4x squared minus 4x. Always use x, okay? So 4x squared minus 4x. Did I do it right? 4x squared minus 4x. Hit enter. And I got my parabola, okay? I'm going to hit, and then notice the vertex or the origin's not in the middle. If the origin's not in the middle, hit menu. Table is, or window is 4. And then standard, I think, is 5. That puts the vertex, or the origin right in the middle. So I'm going to hit menu. Trace is 5. Graph trace is 1. And notice the 0 is 0, 0, right? That's one of my 0, and it's also the y-intercept. Then I'm going to hit the right arrow button and get to the other 0. And I think it's going to be 1. At 1, 0. So my zeros are 0 and 1, and my y-intercept is 0. So the roots are k equals 0 and 1, and the y-intercept is 0. That's all you have to write down, okay? Piece of cake. So just graph these and trace to the x and y-intercept. Remember on number 5, this right here is going to be your y-intercept in it. Okay? Have a wonderful, wonderful day. Remember, you are amazing. You are created to do wonderful things, and you are awesome.